what I'm going to do is talk about how we can, why has it been so hard to work on interceptors, and why is the accumulation of knowledge been so slow? And then I'm going to talk about the relationship between learning and long-term physiological regulation, and then the nature of what's happening now in terms of the study of interceptors. And so, you know, starting out, the answer to the first question especially is it's really hard to work on interceptors, all right? I mean, compared to muscle spindles or whatever, it's really very, very difficult to work on these things. They're deep, they're hard to get to, and animal preparations just very, very hard. And the other reason is that you know, Claude Bernard had this wonderful concept of the regulation of our internal self. And today, we think about feedback, we think about, you know, systems, but for some reason or other, I mean, certainly back in the 19th century, that wasn't the way people thought. They thought in a very top-down kind of way, and unfortunately, we're still there to some extent. And finally, there was some kind of obscure writing that took place, difficult writing, and some bad reading as well. And so here's John Langley, a fabulous neurophysiologist from the UK, and he wrote this book called The Autonomic Nervous System, and in this book he had a statement that said, on this theory, all autonomic nerves were motor. Notice, were motor. How far this is true will be discussed later. And then he died, and so there are some articles, there's some after dinner speeches and all where he talks about extensive work on interoceptors, but in fact it never made it into part 2 of his book. And then unfortunately Gaskell came along and took some statements from Langley and from some of his own work, and all you need to look at is the underlying statement. And the so-called sympathetic system is not a complete central nervous system, but consists purely of exciter neurons. And he wasn't even talking about the issue of whether there were afferents or not. He was talking about some obscure things about whether the dorsal root ganglia had autonomic cell bodies in them. But this statement was taken then, and it sort of discouraged physiologists that, and how hard it was to work on them and how obscure they were from doing very much. And then Walter Cannon came along, and Walter Cannon did some fabulous GI physiology, and for which he is known. And then he went on to, just like Pavlov did, from GI physiology to behavior, and unfortunately, just about the only thing that he's remembered for is this, and the fight or flight kind of concept. This purely efferent organization of the autonomic nervous system. And so, and this was such a compelling idea that in fact it just hung on. And still hangs on. You can look at any textbook, medical school textbook. They're full of fight or flight, and which is not only an incorrect idea, but actually medically kind of a dangerous idea. So even though there was this top-down idea, there was work being done on interoceptors, and I don't have the very nice data from looking at publications. These are books. So this is sort of a favorite toy. This is Google's Ngram, and these are the use of words in 1 million books starting in 1800, and so here's the baroreceptors, chemoreceptors, and down at the bottom osmoreceptors. And you can see that people were working on these things, you know, and so there was actually work being done, you know, and there's this terrific increase in activity about the time that I started working on these things, and then there was this huge crash that took place in 1980, and there are a bunch of reasons for that. But one of the main reasons was that people got really discouraged about these rapidly adapting baroreceptors. It couldn't have anything to do with hypertension, couldn't have anything to do with long-term volume regulation or whatever. And so that, again, and the difficulty and the rise of molecular physiology just pretty much destroyed the field. And actually, this book, anyway, this book, which was published about 1980, came along. If you look at where things happened here, came along at a really bad time, because what Barry did was, and Barry was another student of Neil Miller's at Rockefeller. What he showed, what he claims in this book, is that we can take these very adaptable receptors, these very adaptable visceral afferents, and the only way you can really account for their working on a long-term basis is their incorporation in learning systems. And so in addition to the books that Dr. Cameron mentioned, this is a hard book to get hold of, and you have to pay a lot of money for it, but it's an excellent book, and really brings, I think, interoceptors into the kind of area that we're talking about that we're talking about here. And so in light of the summit, then, my point here is that we ought to be thinking to some extent about how learning might affect and other cortical processes might affect the control of metabolism, and then looking in the other way, how information from interoceptors might actually control other cortical processes, and that's what we're going to hear. We're hearing a lot about in this meeting, and then, as I say, and lots more. So now, the good news is that after a period of there being no study sections at the NIH to work on interoceptors, and very few forms of support, we now have some wonderful research happening. Here are portal receptors, which sense osmolality. When the osmolality of the portal circulation goes down, sympathetic activity goes up, and these receptors have been now thoroughly identified and characterized using molecular biological methods, and interestingly, just an aside fact, these afferents don't travel with the vagus. They actually travel with the sympathetics into the spinal cord and then up. And so finally, some really wonderful work is being done by people. This is work by Steve Liberles at Harvard, and what he did was identify two kinds of receptors, vagal receptors, which are involved in breathing. He's been able to optogenetically code these afferents so that he can stimulate one and cause one change in breathing, and stimulate another, cause another change in breathing. And over here, his most recent paper, he was working on stretch and nutrient receptors in the gastrointestinal tract, and once again identified two of those, one of which senses stretch, and one of which senses chemical factors in the stomach. And so now he's working on cardiac receptors, and so he's just sort of moving along. And here's I think this is wonderful news, because we have had a very hard time in the past, I think, identifying identifying the function, the real function of these of interoceptors, and this seems to be a good way to do it in mice, I admit, but there will be ways to do it in other animals fairly shortly. And then there's some books, and you all know about these books. I don't have to tell you about them. But they are popularizing and generalizing the audience for interoceptors, and of course there has been this major problem because of the lack of study sections, and now there are a whole bunch of sources of funding for working on interoceptors. So here's the SPARK project from the NIH. DARPA has the Electrex program, and GlaxoSmithKline has the bioelectronic medicine, and Boston Scientific has its own funding, and Medtronic has its own funding. And so all of a sudden, there's good funding out there for working on interoceptors for we neuroscientists in any case, and And that's really very, very good news. And I think the very best news is that institutions like this one here are actually devoting their understanding to all of the ways in which interceptors can affect our behavior and as well as our metabolism. Thank you.